we have this queue called ABAP queue pointing to the ABAP side and deserializing my ABAP queue subscriptions. So this ABAP webhook sub, right?
Correct.
Oh, thank you. Can I do that on the command line as well?
For you command line nerd, you can of course do that over kubectl.
There's so many mental and philosophical connections between CAP and RAP, you know.
Hey, Rich, can you turn your camera on?
All right, is that better now? Can you see me?
No.
Hey team, so before we dive into the individual components, I just want to make sure we're all on the same page. I'm going to kick things off at one end, which is the emitter end. I'll talk about that in a second. And we should see things change here in the front end. Okay, now the front end is where our lovely developer details are. We've got at the moment, let's just remember that 374840. We should see a change on that shortly. Now, what I'm going to do, I'm going to manually publish an event message to the sales order created topic. I'm going to use a shell script for that. That's exactly the same topic that will be published for real when we get access to our SAP S/4HANA cloud system. It's for when a sales order is created, right? So I'm going to do that manually, and we should see that go all the way through the brain, the ABAP stack for the charity, your converter, Kevin, and so on. So let me just before we start, just make sure everything's okay. We've got, for example, our sales order API. We've got some sales orders in there. I think I'm going to use like sales order 22 for this first kickoff thing, right? There is the URL for the conversion service, your conversion service, Kevin. You know, sales amount 100 gives us 20 credits. That's all nice. There's a little bit of stuff in the brain just for monitoring purposes. So that's that thing there. And also right now, we can see that the CAP brain, which is this thing here, is listening to the sales order created topic, which I'm about to emit an event message to. And also your stuff, Rich, the ABAP queue is listening on that other topic. So let me kick things off. Let's go to the Keynote Analytics page, 374840, and I'm going to say emit 22. That should publish an event message to that topic sales order created, which it has done. And if we go back across, I'm going to hit refresh on here, 374840. There we go, 515,240. So that is basically a start to end, really quick start to end for all of these components here. So that kicked off with the blue arrow there, and we ended up on the front end. So the whole flow starts out in our SAP S/4HANA cloud system, right? And we've got two pieces to the picture. We've got the sales order data available via a public API, and there's that business event that we looked at just now. Regarding the API, I found everything I needed on the SAP API Business Hub, on the Business Hub, right? So here we go, sales order. This is basically how I found it. It was pretty easy, to be honest. We've got an application to application one, there's a SOAP API, but this is the one we want to the A2X users. That's the OData API. I just noticed, by the way, that there's a whole load more APIs in here for SAP S/4HANA.
Yeah, that's our the S/4HANA on-prem support as well.
Ah, cool. So we got both flavors now. That's awesome.
Yep.
So let me just show you the cloud API. So this is actually what we need, the sales order header. That's so that anybody, including the brain, for example, the brain needs to go and get the sold to party and the sales order header, basically. So that's what we need that for. So we've got exactly what we need from an API perspective. if you look at the details of the API, this is one of the things that finally made me decide to use CAP, which was I can grab the metadata for this API in EDMX format because OData, right? And I just imported that into my CAP application, and whammo, all of a sudden it was assimilated, and I could call this API from within my CAP business logic without even really knowing or caring it was an OData service. That was pretty awesome. That was basically the icing on the cake for me to choose CAP, because I like CAP anyway, right? Anyway, I'll show you more of that later. Down here as well, when I was looking on this page, I saw that there's actually a sandbox, because we haven't got access to the real SAP S/4HANA cloud system yet. We're still waiting for that. So there's a sandbox, and that's what we've been using. Now, when I first tried it, I couldn't figure out what was going on here, but basically you need an API key to authenticate, to credentialize every single call, right? And the API key I found in your preferences, you get one right here, okay? So what I did, rather than make myself and make you inject our own API keys, I built basically a reverse proxy, simple reverse proxy that sits in between any incoming calls and that sandbox, right? And this reverse proxy injects the API key into a header. I'm using the app router because I know the app router and I can configure it really nicely with xsapp.json, any incoming requests. I want to route to the destination behind that API hub sandbox, which is basically the sandbox system itself. And in fact, just going to inject the S/4HANA cloud part to the path to each request as it goes through. But basically, this line is the most important, right? Basically, I want to stick the API key on a header that goes in. And that's why this works. That's why this thing works. So this is all running, by the way, thanks to you, Kevin, on the Kima runtime on SAP Cloud Platform. I'm going to ask you a little bit more about that later, but basically that's what it's all about.
So DJ, the S4 mock reverse proxy, the whole purpose for this is just simply to grab any incoming request and attach the API key, and then forward that to the API hub. So we really never have to deal with the API key when we're calling this services.
Yeah, exactly right. Yeah, all I'm doing is using this before request handler to inject that extra header, and that's it. So you don't have to care. I don't have to care. It's nice. So that's the Sandbox API sales order part. So now just a quick word on the emitter, which we've already used just before, right? It's dead simple. Let's have a look. The script uses the messaging API of the event bus that we're using. And the messaging API is protected with OAuth 2.0 client credentials. So first of all, I need to grab some client credentials from a service key so I can request an access token. It's basically as simple as that. And then I'm just going to send a payload in the event message to that sales order topic. And this is what the payload looks like. It looks pretty cool and professional, right? But I didn't make it up. I had to look around. And in fact, over in the API hub, let's have a quick look at that there. Over in the API hub, there are cloud events defined. And this is where I got the information from. So we got the spec version, the type, the source, the ID, all the stuff I need, including the individual single property in the data part, which is the sales order ID, right? So that's there. I wasn't really sure what to put in the ID, so I just generated, a UUID here. And that's it. All I need to do is publish that message with a single HTTP call here, and we're done. That is the event message. So let me now emit another one. Let's go for sales order 23. There we go. So getting the credentials, access token, wham, we've made the call. That's it. API call done. What we've just done there is basically it's that blue arrow going from the emitter to the message bus.
It's pretty cool, DJ. Can I just ask a question about the technology behind the messaging bus?
Yeah, of course. I've never mentioned that. It's the SAP Enterprise Messaging Service. So we've got an instance of that running on Cloud Foundry. Service is really nice because basically I'm using the AMQP protocol. Well, I'm using the REST protocol there for the API. Rich also wanted to use the HTTP protocol for the webhook subscription, and I'm using AMQP in the brain. So it fulfills all our requirements.
It's pretty amazing.
Okay, so that was the first part. So we looked at Sandbox, we looked at the emitter, but I want to show you a little bit of what I've been doing with the brain. This is that CAP service. The brain's got to do a lot of things. For example, subscribe to event messages that are published to the sales order created topic. So let's start with that. Now, got that also, that's also in this project here. So maybe the best place to start would be actually the EDMX file. So I mentioned just now that the sales order API metadata was available in the form of EDMX. I imported that with CDS import. It assimilated that whole thing, created season from it, and I guess most importantly, it stuck something in my package.json. There's a CDS section here in package.json, and it stuck this stanza in, which basically describes that remote service, right? What type is it? It's OData. Where's the model? It's there. Where is it? It's via this destination here, which I've added these credentials, right? And the really beautiful thing is that, okay, yeah, this is OData. You can see, Kevin, there's yours actually, kind REST, okay, because it's a plain old REST service. That's all that I need to define to be able to connect to it, right? The credentials for it are in the cloud through bindings, through service bindings, but basically I can also run this locally with, using default m.json, for example, with credentials I've grabbed and stored safely locally here. So it works really, really nicely. As well, we've got this connection to enterprise messaging, which also uses those credentials, right? So this is all we need to connect to the instance of the enterprise messaging service. I've got some persistence here in the form of SQLite for local use and in the form of HANA in the cloud. So that's it. These are super important declarative parts of the package.json that allow me then, I'll show you in a minute, that allow me then to connect to all these different things and consume them. The service.cds is dead boring. I've got this charity entry, which basically is just what's behind here. This is how I keep track of how many sales orders I've processed for a given sold to party, because we don't want to process more than 10 or whatever for a given sold to party. So that really, is all there is to it, to the actual CDS definition. The most exciting part is in here. Let me show you. We've got, there's this sort of order limit. I don't want to process in more than 10 sales orders. I'll talk about this in a bit, right? This charity fund thing. Logging is super important. Cloud SDK is part of CAP, and so I want to set the log level to what I want, which is like loads. Even more, I want to set for local logging here. Then I've got some constants. There's the name of the topic that I'm listening on. There's the name of the topic I want to actually publish an event message to eventually, right? When I get through all this. And just like any other CAP application, here's my function that I export from this service.js module, and that's it, right? So more constants. In order to use messaging, await CDS connect to messaging. Bam, done. In order to use the sales order API, same thing. Await CDS connect to S4 sales orders. These are names referenced in the package.json, right? And in order to connect to your service, Kevin, await CDS connect to conversion service. Done, right? But that's not the most exciting part, right? So there's the messaging constant, and I can now use the on event to say basically just like getting on a read or an update or a query or whatever from an OData perspective. I've got this function to handle an incoming message. And what I do is I define a list of properties I want from the sales order header, and then I make this call, right? But check this out. Result equals await S4 sales orders. That's the object I've got from connection to that remote service. Run, select one of these columns where this condition, right? This is SQL. This is effectively SQL. So it's dead easy for me.
Wait, DJ, you're saying you can do SQL against that service? What's happening underneath?
Yeah, right. So let's just double check this, right? So there's the service. There's the service definition in the package.json. Kind OData. What the heck are we doing here? Yeah, we're doing basically something that looks and feels like SQL. Underneath, behind the scenes, CAP is doing all the work translating these to actual OData calls for us, right? So we don't have to care. It's just amazing. So I really like that. So yeah, and also I'm using these same sort of select statements and insert and so on to manage this sort of local entity, the charity fund, so I can keep track of the number of orders and everything. So we've got this little bit of logic here. This is the thing that we check whether, have we processed 10 for a given sales order, for a given sold to party, I mean. So again, we're using this sort of SQL style to, again, not only talk to this remote OData service, but also to our local persistence, right? It's just really, really nice and abstract. So that's that thing there. Let me go back to where we were. Basically, if we decide that we do want to process this particular sales order, the first thing I need to do for that is, given the total net amount, I need to go and get the charity credit amount, right? Because I want to pass that to you, Rich. But this is where you, Kevin, come in, because this is your service. And all I do there is do a converter.get, right? Pass the sales amount and wait for the response. Now that, I'm going to ask you to jump in now, Kevin, because that is this green line going over to your beautiful Go service.
So yeah, thank you, DJ, for the introduction to CAP. Let me show you the Go service where the credit calculation is done.
Cool.
For that, I have this simple Go application here, and basically it's just having this switch statement here where I do calculate the donation credits based on the incoming sales amount, and I pull that out of the URL query right here. Do the calculation, put the response back together in a JSON, and just give it back to you.
Nice.
The whole thing is running on an HTTP server, listening on port 3000, and that's basically it with the Go application. The more interesting part here is actually the Docker file, because not only the CAP service, but also this calculation service is packaged into a Docker image. And the Docker image itself, I can deploy then on the Keyma runtime. So the Docker image is kind of like in the Cloud Foundry runtime, a build pack. With the difference that with the Docker image, I can actually define the environment and the operating system this image has to run in myself, which is pretty amazing. So if I want to deploy the whole thing to Keyma, which by the way runs on Kubernetes, which gives us really, really nice scalability and is super fast and super quick. And here, this deployment YAML is important for me to actually deploy that to the Keyma runtime. So we define it's a deployment. We give it a name, and here we can say how many replicas I want to have on Keyma of that service. In that case, it's 1. Then the whole thing gets exposed over port 3000, and here I can set the resource limits for the memory and so on.
Mm-hmm.
Also here, again, you see the image, right? This is where the Docker image actually lays. So the Keyma runtime knows where to pull it and then install it.
Cool. Yeah, I was seeing that, and I thought that was a GitHub repo, but that's actually part of the GitHub package registry. So that's where the Docker image lives, right?
Correct. That's where it is.
Cool.
So let me show you the whole thing in the Keyma console itself. So if we just go back here, you can actually see there are 3 deployments, and those are the 3 deployments I deployed in there. One is the S4 mock, the calculation service itself, and the brain, the CAP part. And the cool thing is, because I was talking about scalability, I can actually, if we want to scale it up at some point, I can actually just go in here, say edit, and then where the replicas are, I can just say 5 and update. And if I go into the pods here, I can see it spinning up those pods, which is pretty amazing. So this is
Come
how
on, Kevin. Can I do that? Can I do that on the command line as well? That would be preferable for me.
For you command line nerd, you can of course do that over kubectl from the command line.
Oh, thank you.
And yeah, right. The last part here is what's actually pretty cool is if I don't want those pods anymore, you can actually go ahead and just delete them one by one or all of them together without the user ever seeing any downtime, which is pretty cool.
Nice.
And you just saw it, it's terminated and it's gone. And with that, it's pretty much the converter service. So back to you, DJ.
Thanks. Okay, cool. So with that in mind, let's go back to the brain, to where we get the results from that charity conversion. And let's just complete the picture of what else the brain is doing. And then we can hand over to you, Rich, with this new event publication to this topic here. Anyway, so that's where we left off. That's where I called your service. So the only other thing to do now, before I sort of let go, is publish this messaging event to internal charity fund increased. Now we can change the name of that topic if we want. I thought, well, it's internal. I've made it up. I've used again sort of the Business Hub based cloud events reference here to sort of make up a new event. And I'll show you that in a second. All I do, once I've got the conversion amount from Kevin's Go service, I get the creation date and turn that OData v2 wrapped epoch value into a nice year month date, especially for you, Rich, just for you.
Thank you very much.
Well, you're welcome. You're welcome. John Postel is really amongst us in spirit, right? And anyway, all we've got to do now is basically coordinate on this new event message. So what is this? This is the charity fund increased thing, right? Now, in events.js, which is in the same directory as the service.js implementation file, this is where I decided to put the implementation of this new custom event. There, the increased function inside the charity fund object that I export, spec version, type, data content, all that good stuff, right? And I've got a source where it's coming from, i.e. this cap brain service. And the payload is basically here, right? The payload is sales order, cust ID, creation date, credits from Kevin, and the sales org as well, right? So I bundle that up into an event data object, and get this, you thought the SQL for the OData was good. Check this out, messaging emit, that's it. Wrap it in a transaction, basically throwing out an event up into the air to the topic. What was the topic? The topic was, where's that definition now? Okay, so it's internal charity fund increased. That's it. And it just so happens, right, that Rich, you've got a queue subscribed exactly to that topic. So that's it. That's basically what that blue arrow is there.
Okay, so thanks, DJ. So basically, we're going to start in the message bus here, and we're starting at this blue arrow here. So this is basically where we're now moving into the ABAP environment, more specifically the SAP Cloud Platform ABAP environment, also known as Steampunk. So the first thing we want to do is take a look at this webhook subscription that we're subscribing to this particular topic, internal charity fund increased. So let's hop over to enterprise messaging. And again, we have this queue called ABAP queue. And then within the queue subscriptions, we have ABAP queue here. And again, we're listening for any messages coming in on the topic internal charity fund increased, which DJ talked about, right? So then let's take it one step further, and we want to do something. We want enterprise messaging to trigger something when a message comes in through this queue for this particular topic. And what we can do is create a webhook subscription, which I've done here. So this ABAP webhook sub, right? So if we look at this, I already pre-configured this one, and basically it's triggering this HTTP service on the ABAP side, right? We'll take a look at this in a second, but that's basically all the configuration I need for my webhook. I can click the create button here and give it a name, and select the queue that I'm attaching it to. And then here I just provide the webhook URL, again, pointing to the HTTP service on the ABAP side, set the authentication, and I'm good to go, right?
Nice.
So that's the enterprise messaging. So let's flip over and actually look at the HTTP service on the ABAP side. And I'm working with ABAP development tools in Eclipse here. So let's look at the HTTP service. So I have this service here. And again, this is the URL that we just saw in the webhook subscription. And then I have my handler class here, right? So if we dive into our handler class, and DJ showed us earlier the payload that he's sending for this message. And this is exactly what I'm expecting here. I always tend to put what I'm expecting inside my implementation code so I can refer to it as I'm going through my coding. So again, here I'm specifically interested in this section of data. right? So the sales order, customer ID, creation date, credits, and sales order. And what I'm doing in my post method down here below is simply getting the text from the request coming in and deserializing that JSON into my ABAP structures here. So LS payload. LS payload has this structure here, and it's a one-to-one match to this JSON structure here, right? So once I have that in an ABAP structure, I'm simply doing a modify against the underlying database table. And if I was using the ABAP RESTful programming model way of updating this table, I could of course use EML against this as well. Keep it simple. We're going to use a modify directly against the database table itself. Okay.
Actually, that reminds me, I've noticed that this is in a when post, right? So does that means then that the message bus is sending post requests to the webhook endpoint, not get,
absolutely.
Right?
Yes, absolutely.
That's great.
So again, once we're updating this table, let's take a look at the underlying table. Let's see here, open data preview. And you'll notice that the two sales orders that you emitted earlier, DJ, they're showing in the table. So they've come all the way through the process, and we're storing them locally here. And it's important to understand that we're not persisting any data that we don't really require. We're persisting customer name or things like that. We don't want to in fact store that. We only want to store the keys that are vital for our processing. So like customer ID and creation date and things like that. So not duplicating that data across multiple systems is the point here, right? Mm-hmm. So now that we have our data in our table, we want to expose this data using the ABAP RESTful application programming model and create an OData service that can then be consumed by our user interface, right? And the first things that we want to do here is create our views, our interface views for our business object. So our business object being customer donation credits, right? So let's go ahead and open up this particular view. Again, here I'm doing a select against our database table. I'm bringing in I want the sales order, the customer ID, creation date, and here's a calculated column where I'm just interested in the year and month. So doing a substring here and concatenating just the year and month so that I can use that as my grouping for my
for the aggregation. Yeah.
Yep. And then the credits and the sales org. So this is my lowest level business object, right? So we want to create views on top of this lowest level, and one of which I want to create a reporting view, right? So let's look at that reporting view. Again, doing the select against that lowest level business object here, and I want customer ID, and I want that year and month column, and then I'm doing a sum on the credits column to give me the total credits grouped by customer ID and the year and month. So I'm doing that aggregation so that we can expose this data into the user interface, so the user interface doesn't have to do that number crunching. We can do that for them, right? Mm-hmm. So the next section of this is where we actually want to service enable this data. And first thing that we like to do here is create a projection view over top of our interface view. And that's what I have here. So as projection on our reporting view, and I'm exposing customer ID, again, the year and month for creation date. And then we have a virtual column here called customer name. Now, I said earlier that we're not persisting any type of that data where it's not part of keys and we're not using for processing. But in this case, we want to give this to the user interface. Well, how am I getting this? Well, I'm using a virtual element here where we're doing the implementation of that in this class here. So customer master. So let's jump over to that real quick. Customer master.
So actually, Rich, just a question. So basically, everything that you're doing for this is outside of the S/4HANA cloud system, right? You know, it's all here, and anything that needs to be is on the fly. We're not changing anything.
Definitely. Yeah, I mean, this is an extension outside the core, so we're not touching anything. We're only extracting data from the core and doing our processing here as an extension. Absolutely. Yep.
Beautiful.
So as I was saying, the customer master implementation where I get my customer name, I could very well just make a call back to the original mock service using the HTTP client classes that are available in Steampunk. But I wanted to take a little bit of a different approach and use what we refer to as the service consumption model. And let's take a look at that real quick. And this is really cool. This is very similar to some of the functionality that you showed in the CAP, DJ, where basically I grab the EDMX file and I use the wizard here in ABAP development tools, and it generates a proxy for me, which is very cool, right? So I basically downloaded that EDMX file, uploaded it to the wizard. It generated this view for me, which is here. It generated this thing for me. I didn't have to type any of this, right? And it also gives me code snippets. So if we look at that one I actually used here, this read list, I just copy and pasted this code into my implementation class here, made a couple of changes, pointing it to our S4 mock service, right? And did some additional coding down here to loop through my original data and then read the business data that's coming in from that service, and then updating my customer name on the fly.
Awesome.
Right. So heading out to the original source system to bring back that customer name so that I can then publish the OData service and consume from the UI. So now that I have my data that's ready to be consumed and exposed, the next thing I have to do is create the service definition. Very easy to do. If I go to my service definition here, we can say define service, the name of the service, exposing my projection view as credits by month. And it's really that easy. But at this point, we're still protocol agnostic. So we put a service binding on top of this, which is here. Here's my service definition here. It's the binding is OData v2, right? And then I do an activation, and I can even do a preview here to see what my service would look like with a Fiori preview. Or I can go directly to the service URL right there. So we can take a look at the Fiori preview here, which is this is the actual data that's in the table here. So customer ID, customer name. These customer names are coming straight from that core, the S4HANA core, the S4 mock system. And my creation date, which is year and month, and then it's doing the aggregation on the total credits there. And then we have the OData service here, and this is simply what I'm supplying to Kevin for the user interface side, right? So coming back to our picture here, we've talked about subscribing to that webhook. We've retrieving additional business partner data. Again, what we want to understand here is that this is a composite service, right? Exposing customer-specific extension data while also reading in real time business partner data from the backend S4 system, right? And really not touching the S4 core functionality, but seamlessly containing additional data from the core without copying it from anywhere. So this is where we now do this handoff to the front end.
Thank you, Rich, for your introduction. Now I know where the OData service is coming from and talking to. So let me just show you the front end of our whole application here. And before I go in, let me show you this. So this is the UI, and we've seen that in the introduction in the beginning. Basically, it's 3 integration cars. That's what they're called, and with a bunch of charts in there for analytical data. And the cool thing here is this is actually my first UI5 application I've written so far. And it was super easy to me because everything you see here was mostly declarative or written declaratively. So that's pretty cool.
We love declarative.
So the whole thing here is, right. The whole thing here is defined in the manifest JSON, and you can see I have the ID dashboard, and it's an application. And the data source itself is coming from the card manifests JSON, which I'm going into detail a little bit later. But basically, we just have a view. And this view is written in this XML file here in a declarative way. So for example, the shell bar here with the title and the second title, which is this up here. It's just like put in here with this shell bar. And then I'm using a grid container to lay out the integration cards. And you can see them right here. Card, manifest, stack column card, lines card, and the donut card. And this whole thing you're seeing down here, I have in the card manifest JSON. So you can see I've declared that in here with this extension. This is where my data is coming from, and I'm going to show you that in a little bit. But basically, we have the stack column, and we have the line card, and everything you see in between is just really this information here: target, total, and so on, right? And of course, the last one, the donut card.
So basically, the manifest data binding in the view is just bringing in more of this beautiful declarative stuff, right? That's awesome.
Correct. It's pretty cool, right?
Yeah.
And the only implementation code I really had to write is in this extension JSON file, JavaScript file, sorry, where I simply say here, get derived data. That's where I take the data I'm getting and then do some calculations on top of it and putting it in the format I want it to be. But the interesting part is really the get data, where I do a simple fetch request on SAP credits, process the response, do the calculation and all the number crunching up here, and feed it back to the UI. And this, what you see here, the SAP credits, is basically in this XS app JSON, where I say everything coming into that path has to be redirected to this destination wrap, which again is pointing to your service rich. So if I go to the SAP Cloud Platform into the destinations section, I see my wrap destination here. And if I open that up, I see the URL of your service with the basic authentication and the technical user, because I don't want to bother our end users later on with authentication every time they want to view the analytics, right? So I've just maintained it in here. So every request goes into that destination. It handles the authentication against your service rich, and that's basically it.
So also when Rich switches on OAuth 2 and changes the authentication for when we go to production, you can just change that here, and everything's golden.
Correct.
Beautiful.
Correct. I just go and edit, open the drop down, and I have all the beautiful authentication methods in here.
They are indeed beautiful.
Right. And that's basically it. So that's the face of our application.
Nice one, Kevin. So thanks, Kevin. That was awesome. I think we've made great progress here. This is the first time we've really got together. Of course, the other team members, Max, Marius, and Josh, they've also played a massive part in this. So thanks to them as well. But I think for a first stage point, this is brilliant. So, and the really cool thing is, like, we've got all sorts of different things that have really resonated with me. We've got all these different runtimes. We've got Keynote, we've got Cloud Foundry, we've got the ABAP runtime. We've even got Shell, right? My favorite thing. Everything apart from the things that need to be synchronous, everything's asynchronous. Everything's sort of relaxed and organized by the message bus for us, which is beautiful, right? But the most beautiful thing is that we've not had to touch. I know we haven't got access to the real thing yet, but we're not going to have to touch at all the S/4HANA cloud system, which is beautiful. One thing I really picked out today, especially from the stuff that you were showing, Rich, was that there's so many mental and philosophical connections between CAP and RAP. I thought they were worlds apart, but actually, moving from one to the other in either direction, they're close, a lot closer than I thought, which is a really nice surprise.
Yep.
Anyway, I'll schedule the next call for a couple of weeks' time. Thanks, team, and I'll see you later.
Thanks,
y'all. See ya.